Electrical transformer is a static device that steps up or steps down the voltage level without changing the frequency or amount of power being transferred through a magnetic field. It doesn't generate new energy but modifies the voltage and current levels to suit various applications. A single-phase transformer consists of two coils of insulated wire, known as the primary and secondary coils, wrapped around a common magnetic core. The coils are electrically isolated but magnetically linked through the core material. The coil which receives the input voltage from a power source is called primary coil, while the coil which delivers the adjusted output voltage to a load, such as a light bulb, is called secondary coil. The transformers only work with alternating current and are incompatible with direct current. When the primary winding is connected to a DC source, it generates a constant magnetic field in the core of a transformer. A constant magnetic field cannot induce voltage in the secondary coil. However, when the primary winding is connected to an AC source, the varying current creates a varying magnetic flux in the transformer core. The magnetic field has the same frequency as the input current and continuously changes direction and magnitude, expanding and collapsing around the iron core. According to Faraday's law of electromagnetic induction, this varying flux generates a varying electromotive force or voltage in the secondary winding. The EMF induced in the secondary coil causes a current to flow in the load. The changing magnetic field is the key to the transformer's operation, allowing energy transfer between primary and secondary coils. The induced voltage in the secondary coil depends on the ratio of number of turns in the primary and the secondary coils. If the secondary coil has more turns than the primary, a higher voltage is induced in the secondary coil. This is called a step-up transformer. Conversely, if the number of turns in the secondary coil are less than the primary, the induced voltage will be lower, resulting in a step-down in voltage. Such a transformer is called a step-down transformer. In an ideal transformer, with no energy loss, the input and output power are equal. It is the product of current and voltage. Analogously, electrical power resembles the volume of air within a balloon. It's like squeezing one side of the balloon, causing the other side to expand to retain the same volume of air. If voltage goes up on the secondary side, the current must decrease to balance the input and output power. In simpler terms, the higher voltage in the step-up transformer comes at the expense of lower current. Transformers are highly efficient devices, with an efficiency of 95% or higher. However, transformers, like all devices, are not perfect, and the output power is always slightly less than the input power. Real transformers have power losses, including copper loss, hysteresis loss, flux loss, and eddy current loss, which end up as heat that must be removed from the transformer. Copper loss occurs due to resistance in the copper coils. These losses can be minimized using insulated wire with a large cross-sectional area. Hysteresis loss occurs due to continuous magnetization and demagnetization of the core material. These losses can be removed by using highly permeable, soft magnetic core materials, such as iron or silicon steel, to maximize the magnetic field strength. Eddy current loss occurs due to circulating current loops in the conductor. When a conductor is exposed to a varying magnetic field, circulating current loops are induced in the conductor, called eddy current. Eddy current produces heat in the core of a transformer. Laminated iron cores are used to reduce eddy currents. The thin sheet iron layers shorten the current path and minimize the eddy currents. Each sheet is coated with an insulating varnish that forces these currents to only flow within individual laminations. This reduces the overall eddy currents in the entire core. Flux loss typically refers to leakage flux, which is the portion of the magnetic flux that does not link both the primary and secondary windings. Winding the primary and secondary coils one over the other helps to reduce leakage flux and improve coupling between the coils. Transformers come in various shapes and sizes, tailored to specific applications. The most common types include power transformers and distribution transformers. Power transformers are heavy-duty transformers used in power transmission and distribution systems to step up voltage for long-distance transmission and then step down voltage for delivery to homes and businesses. Distribution transformers are mounted on utility poles. These transformers further step down voltage for direct use by end consumers. I hope this explanation helps you understand more about electrical transformers. For related